Moving on to chapter 3, section 3, solving quadratic equations. Anyone know what the degree of the polynomial is if we call it a quadratic?
4.
2. The degree of our polynomials will be 2 today. That makes it a quadratic. Okay? So we're going to be solving quadratic equations. So, a quadratic equation. Hold on one second. Quadratic equation in one variable is an equation that can be written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are just real numbers. Those are just numbers in front of x squared, in front of x, and as a constant. And a does not equal 0. That's another stipulation that has to be there for it to be a quadratic equation in standard form. A root of an equation is a solution of the equation. So we can call a solution a root. So if you hear me say root, I'm talking about a solution of this equation. Okay? You can use various methods to solve quadratic equations, and we're going to talk about all the methods on how to solve them. Okay? So is there any questions about what a quadratic equation is? Or what the root of an equation is?
What is that ax plus what say?
That's
The standard form?
Yeah.
That would be ax squared plus bx plus c. Oh, that's a bad 0. Equals 0. That's the standard form of a quadratic equation. Okay? Any questions before I move on to the next slide?
Wait.
Okay, I'm waiting. I'll give you time to write. Okay, moving on. So here's the 3 methods we're going to look at solving quadratic equations. We're going to solve by graphing. So, to solve by graphing, we graph the equation, and then we find the x-intercepts of the related function y equals ax squared plus bx plus c. Raise your hand if you can tell me what an x-intercept is. Raise your hand. Raise your hand. If you can tell me what an x-intercept is. Raise your hand. Let me call on you.
So the line goes through the x coordinate, the x plane.
X-plane or the x?
Axis.
It's where my graph crosses the x-axis. Right? So anywhere my graph crosses the x-axis, that would be considered an x-intercept. Question? If you want to, these are your notes.
If we gotta do the notes.
I prefer you take notes. You can use notes on quizzes. We're also going to solve quadratic equations using square roots. So to solve using square roots, write the equation in the form u squared equals d, where u is an algebraic expression, and solve by taking the square root of each side. And we're going to look at examples of each of these. And then we're going to solve by factoring. Write the polynomial equation ax squared plus bx plus c equals 0 in factored form. So we're going to factor it. And solve using the zero product property, which we've already looked at a little bit. We've already solved some of our equations by factoring in the past. Any questions about any of the methods we're going to use to solve our quadratic equations?
No, sir.
Can I move on or are we still writing? Okay, I'll give you time. Okay, let's move on. So example 1, solving quadratic equations by graphing. Solve each equation by graphing. It's our instructions. So we have x squared minus x equals 6, or x squared minus x minus 6 equals 0. There we go. How did it tell me to solve by graphing?
Find the x-intercepts of the related functions. Y equals ax squared plus bx plus c.
So I'm just going to turn my quadratic equation here into an equation or a function in 2 variables. And I'm going to graph it. Any ideas how we're going to graph it?
So you can
The 6 is the y-intercept.
Hmm?
The 6 is the y-intercept.
Not 6.
The x.
Negative
Negative
6. Negative 6 will be a y-intercept.
It is?
But how do I get the rest?
Get the, I will subtract it.
Oh, this isn't y equals mx plus b.
That's what I thought it was.
No.
I got it right.
Yes.
When we subtract it in this case, because they're both x's, just one has a,
What do you mean subtract it?
well, from the x and the x, because,
Well, I can't combine x squared and x because they're not like terms, correct?
oh yeah.
Any ideas what I could do to graph this?
Combine them.
Find the slope.
Oh. Does anyone know what the graph of a quadratic looks like? It's not a line.
Is it a?
Is it like a linear function?
It's kind of a U shape, right? We call it, well, you were kind of doing, yeah, you were both
Upside
correct.
down.
It's called a parabola. Everyone say parabola.
Parabola.
So it would be, it's going to be a parabola.
It's crazy.
So I can't just use my slope and my y-intercept to get a bunch of points and draw a line through it and call it good, can I? It's going to be a curve. There is a surefire way to always get ordered pairs for your graph, and that is with a table of values. I can create a table of values. If my smartboard will catch up with what I wrote on my iPad.
It crashed.
So as I was saying, there's a surefire way to always get ordered pairs for your graph, and that's to create a table of values. So I have an x column and a y column. I'm going to pick values to plug in for x. I'm going to plug those values in, and it's going to give me y values, and it'll give me ordered pairs that I can plot on a graph, and then connect them to make my parabola. Okay? So, we're just going to pick some x values. We're not going to, I would say, don't make your x values too big, because when we plug into x, we're going to end up squaring x at some point, because there's an x squared term in there,
You
correct?
can just pick a random number.
We're picking random x values, yep.
Do 3.
A good one that I always like to plug in is 0. That's usually pretty easy to plug in. Everyone know what I mean when I say plug in and get y values out?
Yeah.
So what do I do with 0 here?
Plug it in.
Plug it in for what?
X.
X.
Square.
X.
Plugging it in for all of my x's. What's 0 squared? 0. What's 0 minus 0? And 0 minus 6? Negative 6. So the corresponding y value when I plug in 0 is negative 6. So, like Trey said, my y-intercept is negative 6. Because anytime I have a y-intercept, my x value will be 0, correct? So, my y-intercept is negative 6. It's going to be crossing the y-axis at negative 6. So let's pick some other values to plug in. I'd probably stay around 0. So let's get some positive, some negative. What's another number you guys want to plug in?
1.
1. Let's plug in 1. Just replace all the x's with 1. What's 1 squared?
1.
Everyone okay with that?
Yeah.
Okay, now I'm just working from left to right, subtracting. What's 1 minus 1?
0.
0 minus 6 is negative 6.
0 minus 6?
Negative 6.
Negative 6. So I get 1, comma, negative 6. It's another value I can plug in.
You can do.
Negative 1. We can plug in negative 1. Place all my x's with negative 1. Be careful when you plug in to the minus x. I still have to account for that minus sign, so it's going to be minus negative 1. What's negative 1 squared? Negative 1 times negative 1.
1.
1. 2 negatives makes a positive, so this just turns into plus 1. What's 1 plus 1? 2. And 2 minus 6? negative 4. So I get negative 1, comma, negative 4. Questions there? Everyone with me so far? It's another number I can plug in. Yes? Well, let's see what it's looking like so far. Let's go graph these ordered pairs real quick. So 0, negative 6. My second ordered pair was 1, negative 6. Third ordered pair was negative 1, negative 4. Does anyone see a parabola forming yet?
Yes, a little bit.
A little bit?
Looks like an L.
I would keep getting values till I see like a for sure parabola plugging in. Do we notice? Well, is a parabola symmetric?
No.
Yes.
Yes, it is. If I fold it over, it's going to look the exact same. Or it's going to lie on the other half, right? So it's got a line of symmetry somewhere. So, I do have 2 points right here that if I laid over, they'd lay on top of each other, right? So let's plug in another number outside of 1 and see if it matches up with this point. So what's the next number outside of 1? Huh? 2. I usually like to have you get at least 5 points. At least. What's 2 squared?
4.
4.
Minus 2.
Dude, what's going
I plugged in 2 for all my x's. What's 4 minus 2? 2.
Minus 6.
2 minus 6? Negative 4. Is that going to match up with my negative 1, negative 4?
Yeah, it could.
Yes, it is. 2, comma, negative 4. Everyone okay with that?
They seem a little tough. Like they're gonna be like long.
Where do you think my vertex is?
Your vertex?
4.
Where it changes going from decreasing to increasing.
Oh, 6.
0.5, right? It's between these 2 points. Between 0 and 1, right? So it's going to be somewhere down here. So let's plug in 0.5. I know it's a decimal. You guys don't like plugging in decimals. But we can plug in a decimal.
This is cuckoo.
0.5. 0.5 squared minus 0.5 minus 6. You can actually type that in your calculator just like that. 0.5 squared minus 0.5 minus 6 will give me,
Do we have to do the parentheses?
yes you would, 0.5 squared minus 0.5 minus 6 would give me negative 6.25. So 0.5, negative 6.25 would be about right there. Everyone okay with that? So now we can kind of see the parabola forming, right? We see it going from decreasing to increasing. So I could probably draw my curve now. Like I said, I usually like to get about 5 points, at least. Okay? Now, if I was plugging in negative numbers, it would just keep going up and going up and going up, right? So you'd probably need to change the points that you're plugging in and start going to the positive side. Or vice versa. If you keep plugging in positives, it's going to keep going up. You probably need to start plugging in numbers on the left-hand side, the negative side, so you can see where it's going up. Okay? So there's my parabola.
Is there like a point?
Actually,
It looks like a triangle.
let's get a couple more points real quick. Because I want the exact point of where it's crossing my x-axis. Because those are my x-intercepts, right? This is good stuff. You guys having fun yet?
Not really.
So what's the next number outside of 2?
So
3.
big jump and just put in.
Well, let's see what happens when we plug in 3. Okay? Because that big jump might happen at 3.
Oh,
This is still off of the.
This is all for the first one.
Half of it. That's Mac, I go bathroom.
What's 3 squared?
9.
What's 9 minus 3? 6. 6 minus 6? 0. Uh-oh. Here we go. We get the ordered pair 3 comma 0.
What about me? What'd you say?
Is that crossing the x-axis?
No.
Is my graph crossing the x-axis there?
Yeah.
Yes, it is. Now let's plug in, what's the next number outside of negative 1? Negative 2. What's negative 2 squared? 4. 2 negatives makes a positive. What's 4 plus 2? 6. 6 minus 6? There we go. So negative 2, comma, 0. Is my graph now crossing the x-axis there too?
Yes.
Are those going to be the only 2 points where it's going to cross the x-axis?
Yes.
Yeah.
Yep. We're probably good to stop there then. Okay?
Is there, is there like some crazy big number that like there'd be a new axis or not?
Say it again.
There'd only be up and down. Like on axes, there's only up and down. Or is it like a diagonal plane? Or
What's the
axis
z-axis?
somewhere?
There, in upper level math, you could get into a different plane. That'd be the z-plane, which we kind of talked about when we solved systems of equations in 3 variables. Remember I showed you the planes of the intersections of them? We're not going to graph those in here, though. We're just going to deal with x and y axis from here on out. Okay? So, what is my solution to this quadratic equation based on my x-intercepts? Three and negative 2. So, for letter A, I would put x equals negative 2, x equals 3. And those would be my solutions. Does everyone see that? Where my graph crosses the x-axis are my solutions to my quadratic equation. So that would be x equals negative 2, x equals 3. Does everyone see that? Questions on it?
And then minus, do we do anything with the y-axis?
The y-intercept?
Yeah.
Nope, the solutions are just the x-intercepts. Everyone good? Can I erase letter A and move to letter B?
What you giggling about?
Everyone kind of understands what we're doing now, right?
Yeah.
So I can go through it quicker? Okay. So I can erase all of letter B?
Isn't there a calculator that we could do this on?
Possibly.
Isn't that just a graphing
Dude,
calculator?
I know, yeah.
That wouldn't be doing the work though, Nos.
Well, you would.
That would be cheating.
Okay. Is this a quadratic equation in standard form? No, it's not. How do I get it in standard form? Say that again. Subtract 4x on both sides. That way I can get everything to one side and 0 on the other side. So I'd get negative 2x squared minus 4x minus 2. And there's the equation I'm graphing. That's x. Sorry. Everyone good with that?
Yes.
If everything's not on one side, I got to get it to that side so it's in standard form. Okay? Now I can start creating my table of values, trying to graph it to get my x-intercepts. Okay? What's a good number to always plug in?
0.
0. If I plug in 0, what's 0 squared?
0.
0. Negative 2 times 0?
0.
0. Negative 4 times 0?
0.
So what's 0 minus 0?
0.
And then 0 minus 2.
2. Negative 2.
Did everyone follow along with me just there, or do I need to write it down? Okay. So it was y equals negative 2 times 0 squared minus 4 times 0 minus 2. What did we say 0 squared was?
0.
0. What's negative 2 times 0?
0.
Negative 4 times 0?
0.
Negative.
0 minus 0?
0.
And 0 minus 2?
Negative 2.
Negative 2. Everyone okay with that? So there's my first ordered pair. 0, negative 2. It's my y-intercept. Okay.
Coach Mac.
Hmm.
Go to the bathroom, please. I really have to go.
Make it quick.
Thank you.
Okay. Someone raise your hand and pick another value for me to plug in. We'll see what happens.
1.
8.
5 and 8. Wow, you're picking big numbers.
Way to go, Helen.
11.
If we pick 5, it'll be 5 squared. What's 5 squared?
25.
25. 25 times negative 2.
Big.
Negative 50. 5 times negative 4.
20.
Negative 20. So that'd be negative 50 minus 20, which would be negative 70. Negative 70 minus 2 would give me negative 72. It's going to be way off my graph. Let's pick smaller numbers.
600.
3.
1. I like 1.
I tried.
Okay, what's 1 squared?
1.
1. Negative 2 times 1.
Negative 2.
Negative 2. Negative 4 times 1.
Negative 4.
Negative 4. Negative 2 minus 4.
Negative 6.
Negative 6. Negative 6 minus 2.
Negative 8.
Negative 8. So I get 1, negative 8.
I get it. Pretty simple.
Can I erase? Plugging in 1. Okay, let's pick another value to plug in.
Negative 1.
What?
Negative 1.
Negative 1. Y equals negative 2 times negative 1 squared minus 4 times negative 1 minus 2. Am I moving too fast for anybody, or do I need to slow down? We good? All right. Negative 1 squared. 1. Negative 2 times 1. Negative 2. Negative 4 times negative 1. Positive 4. Negative 2 plus 4. 2. 2 minus 2. 0. So I get negative 1, 0. Does everyone see how the gap from here to here got smaller from this point to this point? So we're probably going in the correct direction, to the left. So what's the next number after negative 1?
Negative 2.
Negative 2.
That's crazy.
Good stuff. This is fun. So y equals negative 2 times negative 2 squared minus 4 times negative 2 minus 2. Negative 2 squared. Positive 4. Negative 2 times 4. Negative 8. Negative 4 times negative 2. Positive 8. Negative 8 plus 8? 0. 0 minus 2? Negative 2.
Matches up.
So I get negative 2, negative 2. Uh-oh, there we go. Now we're kind of going the opposite direction, aren't we?
Oh yeah, that's bad.
Let's plug in one more value, negative 3.
Wait, could we have a negative?
Say it again.
A negative parabola?
Yeah.
Parabola?
If we have a leading coefficient that's negative, it's going to be upside down. So that's the case here. My parabola is going to be upside down.
Yes.
So let's plug in negative 3. It's probably going to be the last number we're going to plug in. So y equals negative 2 times negative 3 squared minus 4 times negative 3 minus 2. Negative 3 squared? 9. Negative 2 times 9? Negative 18. Negative 4 times negative 3? Positive 12. Negative 18 plus 12? Negative 6? Negative 6? Negative 6 minus 2? Negative 8. So I get negative 3, negative 8. Everyone see the parabola forming? And it's upside down? Okay, what is my solution to my equation? Just in general, not necessarily of this one, but in general.
Negative 1, 0.
Where it crosses the
X-axis.
x-axis, the x-intercepts. How many times does it cross the x-axis here?
Oh no.
Once. So I only have one solution here. Where is it crossing? Negative 1. So my answer here would just be x equals negative 1. Everyone okay with that? Questions on solving by graphing? Pretty good stuff, huh?
So,
Okay. Can I move on to the next method of solving?
there's another method.
There's 3. We just talked about 1.
What?
Good stuff.
Oh my god.
So example 2, solving quadratic equations using square roots. All right. Good stuff. So letter A, we have 4x squared minus 31 equals 49. So my goal here is to solve my equation for x. Okay? So I'm using my inverse operations to try to get x by itself. Back to our Algebra 1 days. Okay? So, on the left-hand side, I've got a few things with x. What would be my first step to get x by itself?
Minus 31. Plus 31.
Add 31 to both sides. $49 plus 31.
4, 7, 80.
80. Everyone okay with that step? Is x by itself yet? No. What's my next step to get x by itself?
Divide.
Divide by
4.
4. 80 divided by 4? 20. Is x by itself with no exponents?
No.
Not with.
No, I've got an exponent on my x. Does anyone know or remember how to get x by itself if it is squared?
Don't you divide by 2?
Now divided by 2,
Multiply by 2.
take the square root. Taking the square root is the opposite of squaring a number. So if I take the square root of something squared, it gets rid of it. Everyone okay with that concept? So if I take the square root of here, the square root and the squared cancel each other out. Whatever I do to the left, I have to do to the right. So x equals, do we remember how to simplify square roots? without using a calculator.
Nope.
So what were you saying?
Like how, like 1 times 1 would equal, well, 2 times 2 equal 4, right? And so you
Yeah.
have to do it that way, like instead of having it like 4 times 1, it has to be like 2 times 2, it has to be the same.
So you're saying break it down to its prime factorization? You could do that. So essentially I'm looking for the biggest perfect square that goes into 20. Do we remember what a perfect square is?
Is it like absolute value, kind of?
The same as you multiply each other to make that number.
So a number times itself that gives me that number. Or a perfect square is I can take the square root of that number and get a nice whole number. Okay? Everyone know what a perfect square is? So what are my perfect squares? Is 1 a perfect square?
No.
Can I take the square root of it and get a nice whole number?
Yes.
What's the square root of 1?
-5.
1. Okay? Is 2 a perfect square?
No.
No. Is 3 a perfect square? Is 4 a perfect square? What's the square root of 4? 2. Because I can get a nice whole number if I take the square root of 4. Right? What about 5?
No.
6?
Yeah. Wait, no, because no. Yeah, you're
7?
No.
8?
right. Yeah. Crap.
9?
Yes.
What's the square root of 9? 3. So, 1, 4, 9, 16, 25, 36, 49. Those are my perfect squares.
64.
So if I take the square root of those, I get nice whole numbers. Does that make sense? So what's the biggest perfect square that would go into 20?
2.
Not 2,
5.
4.
Oh.
So I would break this down into 4 times 5 under the radical. Did I keep it equivalent to here? Is the square root of 20 the same thing as the square root of 4 times 5? Yes, it is. Okay? Now, hopefully, I don't know if you guys remember this or not, but the rule of radicals, if I have two things being multiplied under a radical, I can split them up into their own radicals. Does anyone ever remember learning about that?
Yeah.
Ish. Now, what's the square root of 4?
2.
2. Can I take the square root of 5 and get a nice whole number?
Nope.
So there would be my answer. Everyone see that? Questions on letter A? We kind of remember simplifying radicals.
Yeah.
The way Nos was explaining it is you can make a factor tree for 20. What two numbers multiply to give me 20?
4 and 6. Wait, no. 4 and 5.
4 and 5. What two numbers multiply to give me 4?
2.
2 and 2.
Like a tree.
Are there any other numbers that multiply to give me 2 besides 1 and 2? No. So 2 is a prime number, right? This is what we call the prime factorization, the factor tree of 20. Is 5 a prime number?
No.
Yes, it is. Nothing multiplies to give me 5 except 1 and 5, right? So there's the prime factorization of 20. 2 times 2 times 5. So what we could do is pull out pairs of things. Do I have any pairs of anything?
A pair of 2s.
Got a pair of 2s. If it has a pair, I pull it out of the radical. If it doesn't have a pair, it stays under the radical.
So you take out the 2.
Does that make sense? So I pull it out of 2. 5 stays under the radical, so it's 2 radical 5. It's another way of looking at it. Questions on that?
No.
Are we okay?
Ready for number B.
Are there any questions before I end my recording? Because we're going to stop there.
Will we not have to deal with any fraction words like that?
What do you mean?
Like C?
You will.
Wow.
We'll finish the notes tomorrow. Are there any questions about what we've covered today, though, before I end the recording?